Okay, section 8.7 is the last section of this chapter, so let's get on it. It's called vectors. You may have heard the word vector here and there, but what we're going to do is give a more specific definition to something that you may have heard of before. This is going to be very, very helpful when you take physics. So when you get there, you can look back on this and hopefully it might help you out a little bit. Basically, vector is a quantity that has two things. And here's the two things that you really need to know about a vector. Okay, a vector has a thing called magnitude. Talk about that here in a second. Magnitude. And the second thing is direction. So it's very important that you understand that a vector has these two things. Magnitude basically means like how much of something. So for instance, if we're driving down the road and we want to know how fast we're going, you look at the speedometer, it'll say, of course, 55 miles per hour, and that means how much. That's the magnitude. That's not really a vector. Just knowing that you're going 55 miles per hour does not say anything about where you're going. It just says how fast, how much of something. The direction, of course, says if you're going north, if you're going 55 miles per hour north, then you've described a vector. Just saying 55 miles per hour is not a vector. Just saying that you're going north is not a vector. You put the two together, and that's considered a vector. So that's really, really important right there, that a vector is two things. It's got magnitude, how much, and it's got direction. Of course, it's pretty obvious which direction are you going. All right, so how are we going to write this out? Let me jot something down real quick here. Okay, I've drawn a arrow right here with the X and Y axis. I didn't show too much of the second, third, and fourth quadrant. We're just sticking right here in the first for right now. So I've got an arrow. It looks like a ray. All right, it's ray AB if you want to call it. But this is also considered a vector. So if I was talking about the magnitude of this, what I would do is find out like how long this is. Now, it does have an arrow on the end. The arrow just indicates that it's going off in a certain direction. But if I actually went from point A to point B, that has a length, that has a distance, and I would just put AB. All right. If I don't put any line segment over top of it, it means the length of line segment AB. We talked about that way back in the beginning. Now, the book puts this absolute value there, and the absolute value indicates that it's always going to be a positive number. Right? We'll talk about the direction in a second, but the magnitude is always considered a positive number. A lot of times you'll see it written like this. Instead of an arrow over top of it, it's kind of like a half arrow. So it's a line with just half of an arrow. That indicates that it's a vector. Now, right now, we don't know the direction. Okay, so right now it's not considered a vector, but that's how you would write AB if you considered it as a vector. So that's what we'll do right there. Now, it's missing something. That's the magnitude. That's the length of AB. So if I said it was like 5 inches or something like that, that's how much of it is. But I also need a direction. And the direction always starts from the positive x-axis. We call this in standard position. If you start at the positive x-axis, and what we're going to do is going to go counterclockwise until we get to that line. So if I start from the positive x-axis and I go counterclockwise, now you understand a clock goes this way, right? So it'd be 12 o'clock, 3 o'clock, 6 o'clock, 9 o'clock. So this would be clockwise, but if you go this direction right here, from the positive x-axis up to that line, then that is the direction that we want to go. That's counterclockwise. So whatever angle that is, in the book they put an X and a degree right there. So whatever angle that is, that's our direction. That's how we show the direction of a vector. We show it by an angle. There's other ways to do it as well, but for right now we're just going to say that the direction is an angle. So again, it starts at the positive x-axis. Don't start over here or up here or down here. It always starts at the positive x-axis. It goes counterclockwise until you get to your line that you're talking about right there. So that kind of indicates a magnitude, length AB, and a direction that would be that particular angle right there. Now, we haven't put any numbers in. We haven't really done anything with it yet. All I'm trying to show you is how we label a vector and the different parts of the vector. Let's break this down just a little bit further, and we're going to talk about the components of the vector. Okay, let's rename this vector right here. We could have called it AB like that, but most of the time what they do is they usually give it a lowercase letter. Instead of using the 2 points here, usually they just pick one letter. It all depends. And we'll call that vector W. Okay, we'll just call it W just to make it a little bit easier. What we're going to do is going to break it down into its components. What I mean by its components, the parts that make up the vector. So let's think about this. If this is our origin right here, and we wanted to get to point B, notice I took point B from here and I just put it at the top of the arrow. It's kind of how they do it in the book, so that's why I did it here. If you wanted to start from point A and get to point B, and again, you're talking about X and Y axis right here, how would you get from this point to this point up here instead of just going along that straight line? Remember, you could go in the X direction and you can go in the Y direction. So let's drop this about right here. So watch this. I could, let's kind of make a triangle out of this. We could go in the X direction that far, and then you could go straight up in the Y direction. Oops, I didn't want that. There we go. So this right here would be the X component. All right, that's the X part. That's basically what component means, the parts of it. This is the X component, and this right here would be our Y component. So we have the X component and we have the Y component. And so what would this point right here be? If I went over this far on the X and I went this far on the Y, this is actually an ordered pair, and we call that point right there XY. Pretty simple. So we took a vector that had a magnitude and it had a direction. Now we didn't really know the direction on this particular one, but if we had a vector right here, you can break it down into its components, and that's some of the things that they're going to ask you to do. Again, we haven't put any numbers in. I'm just trying to give you an overall view of what's going on here, and then we'll eventually put some numbers in. This is in standard form. Okay, the standard form, by the way, they call this point right here where you start, because notice the arrow is here, so it starts at the point A, and it goes in this direction, the direction of the arrow. We call this the initial point. The initial, meaning the beginning. Okay, that's where you initially start. That's the beginning. We call this point right here, point B, we call that the terminal. Terminal means the end. All right, so that's called the terminal point. Let me see if I missed anything else. And yeah, we say this whole thing is in standard position because it's on a coordinate plane. It's got the initial point is at the origin, and then it goes in a certain direction. There's the terminal point, so we call that standard form. Sometimes they do this. Instead of writing an ordered pair for this thing right here, they'll write it like this. It depends on the book. I really haven't seen it. I've taught out a few other geometry books. I haven't really seen this, but this book writes it like this. I've seen it several different ways, but they write it instead of like just a regular parentheses. They kind of do. It's probably not even that thin. It's probably a little bit more like that. Okay, and then you just put X and Y. Kind of looks like an ordered pair, like that. Okay, that's the component form. Let's write that down. Component. This is the component form of a vector. So you can actually write a vector two different ways. You could write a vector in its component form, or you could write a vector with the magnitude and with the direction. Again, I haven't put any numbers in here, but eventually we will. All right, might not make so much sense right now, but after we start doing some examples, I think that'll make a little more sense. And in fact, let's do an example right now. All right, look at this crazy thing. Here's what they ask you to do. They say write the component form of vector CD. So you start at C and you go to D. So this C goes with that point and this D goes with that point. The component form, remember what the component form is? It's X, comma, Y. It's in those little arrow brackets or whatever you want to call them. So what we want to do is we want to find out from point C to point D, how far is it along the x-axis. So if I went from here to here, how far is that? And then if I went from here to here, how far is that? Well, you could just count if you wanted to, or you could just do a little bit of math. Watch this. If I wanted to find the distance I went on the x, how would I find the distance of the x? I would just go 4 minus 0. Then how do you find the distance of the y? Subtract in the same order, so it's going to be 1 minus negative 1. and then you work that thing out. That's 4. 1 minus a negative is 1 plus, and that's a 2, and that would be the component. And what did you just find right there? You found that going along the x is 4, and then going up the y is 2. So you could have just counted 1, 2, 3, 4 right there. See, from here all the way to there is 4, then from here to here is 2. So that would be your component vector. The component form of the vector would just be the component 4, 2. All right, that's not so hard. Let's do this one right here. Let's do the red one. Oh, let me change something real quick. There we go. Oh, goodness. Let's try this again. There we go. Sorry, I have no idea what I'm doing, but I'm just changing the size of the pen. So we'll just do it right here. Let's find the component, or write the component form of PQ. Now I call it PQ because it's starting at the point right here, and the arrow is going in this direction. So that's your initial, that's your terminal. So your beginning and your end. So you start here and you go here. So if I wanted to, I could just do the math on this. So I'm starting here, so I'm going to go -1 minus -3. See, -1 minus -3. And then for the y part of it, I go 3 minus -1. 3 minus -1. Let's work that thing out. That's going to be a plus. -1 plus 3 is 2. And then this would be a plus, would be a 4. So that would be your component vector. Now again, what did you do? You found out the width. Let's make this a little thicker so I can draw it on here. What you did is you found how far over the x is and then how far the y is from there to there. Now you did it just by arithmetic, or you could have just looked at it and counted. You could have drawn your triangle and you could have said, oh, I go over, so 2 on the x, count it 1, 2, and then how far on the y? 1, 2, 3, 4. So you could have always just counted if you wanted to, but I think it's just as easy just to do the math on it. You see your ordered pairs. What if it wasn't drawn for you? What if you just said you had vector PQ, they told you point P and point Q? You didn't really have to draw it out. You could have just subtracted the x values and got 2, subtract the y values and got 4. All right? So that's as easy as it is to find the component of those. Well, I'm going to have to backtrack a little bit. I was looking at the example in the book, and it's like, oh, they got negatives here. Why'd they get negatives? And I figured it out. So I kind of messed up a little bit. Oops, what did I click on that for? Oops, trying to get that red. There we go. Okay. What I should have done was this. I started here, and it definitely matters which point you start. So I started here. I should not have gone down. See, I started here, went over this way, and then up that way. But look what direction the arrow is going. The arrow is going in this direction. So this is my initial. So I have to go the x direction, then the y direction. So I really should have gone this direction, and then I should have gone this direction right here. So if you take a look at this, I went to the left, which is -2, and then I went down, which is -4. So this really should have been -2, -4. Now, how could I have figured that out doing it mathematically here? Well, you would have had to do this. It's always the final minus the initial. Notice this is the final point right here. So I really should have gone -3 minus -1. Right? And then I should have gone the final minus the initial. I should have gone -1 minus 3. Sorry for missing that. I hope that didn't confuse you too much. So I should have -3 plus 1, which is -2, then -1 minus 3, which is -4. That makes a little bit more sense, I hope. So again, it matters your direction. It matters where you start and where you end. So in order to get from my initial point to my terminal point, I had to go in the x direction, which would have been left, which is negative, and then I would have had to go down, which is negative, 4 places, and then I would have got the -2, -4. Sorry for the confusion on that, but I hope we straighten it out. Let's go on to another little bit of a topic here. Okay, now we're really getting into a good example right here. This says, find the magnitude and direction of vector RT. So it starts here and it goes through here. And here's the 2 points that make up that vector. 2, 4, and -3, -2. So we want to find the magnitude, how far, the length of that line is really what we're finding. Okay, we're finding the length from R to T, or the distance, right? The distance to those two. And then we're going to find the direction. The magnitude, a little bit easier, I think. because you're just finding the length of a line, the length between, or the distance between 2 points. And we already have something that allows us to find the distance between 2 points, if you remember, and that would be the distance formula. And it's not been too long since we've done that stuff, so let's write distance, and let's do our little distance formula here. This would be a good reminder of the distance formula. So it's x1 minus x2. So we start here, so it's going to be 2 minus negative 3. And then we do the y's, it'd be 4 minus negative 2. 4 minus negative 2. And then keep the square root. This is going to be plus 2 plus 3, that's 5. We can do that in our head. 5 squared is 25. Plus, that's going to be a plus right there. It's going to be a 6, 4 plus 2, and that's going to be a 36. And then we can add the stuff inside there. That's a 5, carry the 1, that's a 61. You could just keep it the square root of 61. I'd be fine if you did that. The book keeps it like this, or they put it in the calculator as well, and you could get about 7.8. So what is the magnitude of this vector? The magnitude is 7.8. That's the length of the vector from R to T. That's what you're finding when you find the magnitude of something. You're just finding the length of it. And since there's 2 points, I can just use the distance formula, and I can find that fairly easy. Now we want to do the direction. Here's another way. Here's another thing that I could have done as well. Let's do this in blue. So I could have done this. Remember, we're going in the x direction, then the y direction. So I could have gone in the x direction that far, and then I could have gone in the y direction that far. Let's push this over just a little bit so it matches up. There we go. Okay, and what you could have done is this. You just could have counted over if you wanted to. That'd be starting here. That'd be 1, 2, 3, 4, 5. So that would be 5, and then you count down. You're at 4. Then there's 1, 2, 3, 4, 5, 6, and that would be 6. And there's your 5, and there's your 6. You could have gone Pythagorean theorem with this. 5 squared plus 6 squared is 36, or 25 plus 36. You get 61. It's the same exact thing, but it saved us from doing all this. But that's kind of helpful, though, to have that right triangle there. So I'm going to keep that right triangle right there. I don't really care right now what that actually, yeah, we'll keep that. We'll keep those numbers in there. I think it's probably good to have those numbers in there. What we're going to do now is find the direction. Now the direction can be just a little bit tricky. This R is kind of in my way, so I'm just going to get rid of it. We already know what it is and where that point is. I'm just going to get rid of it. We want to find a direction. Now remember, we have to go from the positive x-axis to the vector, but we're not really going to start here. I need that point to be at my origin. If you look before when we talked about this, this point was at the origin when I found a direction. It's got to be in standard position. So I'm not going to move all this stuff down to here. What I'm going to do is I'm going to bring the origin up to that point. I'm like, what in the world are you talking about? So watch what I'm going to do here. I'm going to make just like a little improvised x and y axis right here, and it's going to be part of that blue line and right there. So all I did was kind of made my own little x and y axis. Why did I do that? Because I needed to find the angle from the positive x-axis all the way until we get to that green line. So this is the angle that I'm looking for. I'm looking from here all the way to there. That's the angle. See that big angle right there? That's my direction, because I always got to start at one spot so we're consistent. I'm always going to start at the positive x-axis. I'm going to go counterclockwise until I hit my vector. That's where it's going to be right here. So I took the x and y axis and I kind of took it and brought it up to this. So now the initial point of my vector is at the origin. I hope that makes a little sense. That's always a hard thing to understand at first. But after we do it several times, I think it'll make a little bit more sense. Okay, first time you see something new is always a little bit tougher. So what I'm going to do is I am going to figure out one of the angles. Now watch. From here, this point right here, all the way to this point right here, how many degrees is that? Well, it's a straight line, isn't it? It's from here to here that forms that straight line, so that is 180 degrees. But that's not the angle that I want. From here to here is 180, but I got to go this little bit right here. That's what I don't know. I don't know that angle right there. Okay, I'm really messing that up. But I'm trying to find that angle. So how do I find the total direction? I would take the 180, which goes to there, and then I'd add this little tiny bit right here. Problem is, I don't know that little bit, but I can find it. I've got a right triangle. I have two sides of my right triangle. I actually have three sides because I know that's the square root of 61. But I know these. These are a little easier. I know these two sides. I should be able to find this angle right here. If it helps, I don't know if it helps or not, but you could redraw it. I'm just going to redraw it off to the side. It doesn't have to be to scale. It's just so that we get a better idea of what this thing looks like. Remember, that's the 5, that's the 6, that's that, and we are trying to find this little angle right here. We'll call that theta. Now, without all the junk around it, it looks a little bit cleaner. It looks a little bit nicer to work with. So you should be able to solve for theta right now. So look what we have. We're not going to use law of sines, law of cosines, because I have a right triangle. But look what I have. I've got an opposite, and I have an adjacent, which trig function uses opposite and adjacent. That's right. That's the tangent. So it's the tangent of theta equals the opposite, which is 6, over the adjacent, which is 5. And now we'll solve for theta. We'll just put this into a calculator and then take the inverse tangent of 6 over 5. So let's do that. Okay, here's the calculator. So we hit second function tangent, hit 6 divided by 5, and we hit equals, and there it is. It's about 50 point, we'll round it to one decimal place. We'll go 2. 50.2. So theta is 50.2 degrees. But is that my total direction? Is that the direction that I want? Not quite. It's close, but not quite. Remember, the 50.2 is right there, this one right here. But what do we want to find? We want to find from the positive x-axis all the way to the green line. So it's going to be 180 plus the 50.2. All right, and so you're going to get a 0.2 right here, you get a 0 right there, you get a 3, and then you carry the 1, and that is 230.2 degrees. That is the direction. So you actually have two answers here. That is part of your answer, and this is part of your answer. So what we're going to do is we're going to put it all together. Let me see how they do this. In the book I used to teach out of, it did it one way, but and again, different authors write these different ways, and you can just write it like this. We can say that RT, watch this is how I'm going to write my final answer. I'm going to write vector RT is, yeah, they just put units, because we don't know if it's feet, inches, or miles per hour, or what it is, okay? So we'll just say it's 7.8 units, and then we'll just say at, you know how that ampersand thing right there? Okay, we'll say at 230.2 degrees. Remember, a vector has to have two things. It has to have a magnitude, and it has to have a direction. And they tell you right there in the instructions. There's your magnitude, there's your direction. That right there is how you want to write your final answer. So it really wasn't that hard. The explanation was probably worse than anything. But let's go through it very quickly on what we do. Magnitude, how do you find that? It's the distance between those 2 points. You throw all that into the distance formula. The direction was the hard part, but what did we do first? We broke it down into its components. So we started at the initial, we went in the x direction, and then we went in the y direction to get our right triangle. Okay, you could have subtracted to figure it out, or you could just count it over. That's 5, that's 6, but you need to find this angle right here, so we used the tangent, because that's opposite over adjacent. So we found that little angle right there, which is 50.2 degrees. That's not our final answer. Our final answer has to be taken from the positive x-axis all the way counterclockwise until you hit that green line. So it's going to be that 180 plus just a little bit more, the 50.2. You add them up, and that whole angle right there is 230.2 degrees. That's how you find the direction.